All right. So we talked about what an AI model is. Now let's see how you can train an AI model. First of all, let's see an analogy with this one. To train an AI model, the first thing you need is a problem statement. So what is your problem? What you want to solve? For example, in case of a large language model, you want to understand how the language works and you want to able to train that model. It is able to respond to any general queries that has been responded by a human. Now let's take an analogy. For example, in this case, we have a person who want to get a full driving license and you want to learn how to drive. The first thing is you will collect and pre-process the data. Now, just to get an analogy with the example that I've given, whenever you are going for a full driving license exam, before that you need to train yourself, right? And before you start training, you evaluate what is your current skill, how much you know about driving, what you know about the road safety rules and all. So that part is called collect and pre-process the data. So pre-processing the data means you clean the data, you analyze the data that you have, and it's a limited set. Just an example that you have that limited knowledge of the driving skills of the person. Similarly, you have the data, but you have the limited knowledge how it can be used. Then you choose an algorithm. So whatever algorithm that you decide, you are going to use, and there are n number of algorithms available. So these are the types of algorithm available. I'm not going in detail, but these are some common one. Linear regression, which maps a linear relationship. Logistic, which maps the relationship between two variables. And then you have decision trees, you have naive Bayes, k nearest neighbor or KNN. Then you have magging, and the last one is deep neural networks, which is a layered structure of many algorithms. So this one is relevant to us because when we talk about large language models, we are essentially talking about how to build deep neural networks, which is layer of multiple algorithms. So we have chosen an algorithm. So just to compare with the analogy, this algorithm is how you are going to teach the person how to drive. There are multiple ways you can tell the person to drive. You can start with a simulation environment like off-road, have some comfort on the training wheel, move into a training area where there's no traffic, and then slowly start into less traffic area. So this is an algorithm how you start training that person. So that's the part where we are actually training the model. So this model, we train that in a limited set of data, and that limited set of data is called the training data. So now, as I've given you an analogy, you train that person in a limited environment, in that with a limited set of their driving knowledge, and then you evaluate what is their skills. So then you evaluate how the model is behaving. You get the responses, and then you see the deviation, what is the accuracy level, and which aspects of the responses were highly deviated from the actual response. And here you might need some support from human so that they are able to accurately depict how the response is behaving. One of the biggest example of this one is the reCAPTCHA that you see. So this is a reCAPTCHA image, and you might have seen this whenever you're trying to submit a form. You might see these reCAPTCHA images, and what it does, it's actually validating the response. Now how it works, this reCAPTCHA, earlier we used to have text analysis, right? If you remember, used to submit a text. That was part of the optical recognition where Google was working to identify and read the books. Whatever words I'm not able to identify, the Google bot or the reCAPTCHA bot is not able to identify that word, you help them. Similarly here, whatever bot is not able to identify in the image, like for example street lights or you can say the traffic markings, wherever the error rate is high, it sends it to human so that human can identify which one of them is accurate traffic light, which one of them is correct traffic light, and which one of them is the correct street sign. So here you are actually helping the reCAPTCHA bot evaluate their responses and get better result. So this is kind of an assisted way of learning where you are identifying the correct response for an AI model. Now, why it is being used for street sign? Because this would soon become a part of self-driving initiative where cars are able to identify what are street signs, what are the traffic lights and all. If I talk about the analogy, this evaluation of the model is similar to going for either a pre-test or kind of an actual test where you look into the ways where you have where you look into the ways how your driving skills have improved. So if you evaluate the model and the accuracy is on the higher side, then you see that the model is okay for sending to for deployed in a production environment. And similarly, if you in case of driving, if your skills are improved to a level where you can clear the test, you can drive in a real environment. In case your skills are not up to mark, you will go and retrain yourself for your driving capabilities. This is something that we can do to fine tune the model as well in case of an AI model where you improve the model by providing more data and improving the algorithm as well. So this fine tuning of the model is required so that the actual output is better. And then the last step, that is deployment of the model in production. So in case I compare this with GPT-3, GPT-3 was announced in 2020, but actual deployment of model was done as part of a chatbot was done in November 2022. So you can see they took a lot of time to fine tune the model, and currently as well, right now as well, there are a lot of shortcomings with GPT, which is basically the areas where the AI model is not able to get the proper training and it still needs more data to train upon. So that's why GPT-4 has a larger data set so that it's able to train in a higher data set so that the accuracy is higher.